Check, testing, testing. Check, testing, 1, 2. Good afternoon, everybody. I brought like a, here I brought, this way, here. I brought a guest today, Spartacat. ECC shared some like Zoom backgrounds we could use. I'm all over it. Let's see, let me get the homework up. Share here. Let's see. Yeah, share. There we go. Okay, let me just start. I've been trying to do this lately and just kind of ask, does anyone have any big picture questions about timing, the class, upcoming stuff, schedule, college questions? You know, anybody have, oops, am I recording? Yep, I'm recording. Okay, good. Anybody have any questions that you've been thinking about that you just wanted to start the class off and ask about? Hey, Rudy, we're just starting with trying to see if anybody has any questions about kind of the class and or the college this semester. Any big questions?
No, not about that.
Okay. Anybody else have any questions? Anything you've been wondering about? 16.3 and 4, correct. Just those two. Yep, just 16.3 and 16.4 will be due this Thursday. I did not assign any additional videos for today, so we're still focused on triple integrals for today. And then I did finish the 16.5 video, so I'm going to ask that you watch those for Thursday, but we will not have that homework due on Thursday. So we'll do homework questions on 16.3 and 4 today, and then continue with that on Thursday, and then I'll have some additional examples from 16.5, which will be triple integrals, but now in new coordinate systems. So the triple integrals weren't fun enough. Now we're going to do new coordinate systems for triple integrals. So that will be at 16.5. I do have good news though. 16.6 is one of the sections that we are going to skip. I don't know, did anyone do in Calc 2, did you do centers of mass? Like centers of, like you have I almost want to say plantar fascia, that's your foot. What do they call it? It's like a planar region, and you find the center of mass of it, like if you're going to balance it on a pencil. Did you ever do that in Calc 2?
No, we never did.
Physics,
we did
Michael
in
said.
physics.
Yeah, physics.
Yeah, we did in physics.
Yeah, some Calc 2 is like an optional topic in Calc 2. And so really it's the same thing here. It's like a 3-dimensional thing. So if you have I just grabbed something that looked weird here. So, or not weird, but like unusual dimensions. So my son was playing the Xbox controller, like where would the center of mass be of this? But it's 3-dimensional. So it's just a 3D version of that. And it's definitely something that you could look up on your own if you needed to. So we're going to skip that. And move on to chapter 17. And we'll hit up a couple of sections from chapter 17 before we have our next test. So I'm thinking like a couple weeks from now will be the next test, a couple weeks. We want to finish up, we want to do 16.5 and then hit a couple of sections from chapter 17. I have that due next week. And then the following week would be our next exam. So that is my plan. Any schedule related questions? All right. Okay, let's start with homework questions. I have 16.3 and I have 16.4 up as well. So who wants to get us started?
I did have a question on 16.4.
Okay.
It was number 21. It's page 1044.
All right. I do not have the pages because I
Okay.
found a way to download.
Oh, even better.
And it's much, yeah, it's much better. 21, you said?
Yeah.
Wait, no, I was looking at 20. We did 20, but 21
Yeah,
we did
20.
not do. We did not do 21. So let me grab this. We're going to try to find the volume. All right. Go over here, paste, and resize. Okay. All right. There's a sphere and a hyperboloid, and we're trying to find the volume of the solid between them. So I think because we have like the top and the bottom, it seems best to integrate in terms of z first, to do z first and then do x and y. So we need to get z for each of these. Let's see, z squared would be 19 minus x squared minus y squared. And this would be the top half of that. So square root of 19 minus x squared minus y squared. This is interesting. I'm always suspicious of these when they have a weird radius. Like, why would you have a sphere radius square root of 19? Just wait. I bet it will make the math work out nicer later. And then the hyperboloid similarly would be z squared equals 1 plus x squared plus y squared. And so z equals square root of 1 plus x squared plus y squared. Okay. And then when we set up our volume, if we do dz first, it would be from the square root of 1 plus x squared plus y squared, that's the hyperboloid, up to the hemisphere, square root of 19 minus x squared minus y squared. So that's the innermost integral in terms of z. I feel like we had a similar, like a consistent process here. Does anybody remember what we needed to do next?
We need to find the section between the two regions.
Yep, you got it.
Each other.
Yep, you got it, Max. So square root of 19 minus x squared minus y squared equals square root of 1 plus x squared plus y squared. So we square both sides. Let's see, subtract 1, we get 18. Add, see, I'm onto them. Totally called it. 18 equals 2x squared plus 2y squared. Divide both sides by 2. Oh, how convenient. It's a circle radius 3. So that's why they did a sphere radius square root of 19, because it made this work out nicely here. So that's our region. I have a suspicion for what I would do next, or I have a thought about what I would do next. So the x squared plus y squared equals 9 is the intersection, and then of course the region R is inside of that. That's the region we're integrating over. Does anyone know what I am thinking about, what this kind of hints at next? I'll give you a hint. The shape of, yeah, right. The shape of the region is a circle. So that tells me, I mean, I can do rectangular, but then I'd have to integrate from negative y equals negative square root of 9 minus x squared to positive square root of 9 minus x squared. And then x would go from -3 to 3. Ugh, gross. Or I could just do, let's see, r dr. R goes from 0 to 3. D theta, theta goes from 0 to 2 pi. So that's a lot. Whenever you have a circular region, you should think, you know, can I do polar coordinates? Okay, we have, before you can do the integral, we have a problem in here that we need to fix. Does anyone know what the problem is that we will need to fix?
So our bounds are in terms of x's and y's. Should we
Correct.
switch those to polar?
Mhm. Yep, we need them in terms of polar. So the 0 to 2 pi is fine. The 0 to 3 is fine. X squared plus y squared is r squared. So square root of 1 plus r squared. And then the top one there would be actually 19 minus r squared. You think the sign's the wrong sign, but when you factor out the -1, 19 minus, and then it's x squared plus y squared. So you still get the r squared there. And that's dz r dr d theta. And then I think you're good to go. That's usually the hardest part. I don't know if that helps you, Rudy. I don't know if that's enough.
Yeah, that's pretty much like all I had trouble with, so that should be good.
Okay, all right. You know, sometimes it's not like these integrals are super easy, but usually the thing that slows people down the most is the setup. So that was a good, I'm glad you brought that one up. That was a good question. Any additional homework questions? We're looking for homework. We have 16.3 and 16.4 are both due this Thursday. So any additional questions on either of those two sections? All right, Leslie has a question, number 11 on 16.3. Oh, look right there. Find the volume of the solid. Okay. Actually, let me redo that. Let's try that again. We'll get the whole instructions too. All right, and the volume of the solid bounded by the surface in the xy plane. Interestingly here, like now I kind of want to do this as a triple integral, but the way that we had set this up, this is a little bit different because I don't know, you could do them both. We could have done the last one as a double integral. So if I look up here, you can kind of see, I don't know if you can see where this first integral is going to go, but it's just going to give you a z from the bottom surface to the top surface. We actually could have set this up as the integral from 0 to 2 pi, the integral from 0 to 3 of the top surface minus the bottom surface r dr d theta. We could have, this could have been a 16.3 problem. We just were doing it as a triple integral, where to find the volume as a triple integral, you just integrate dv. So the connection here to Leslie's question is we want to find the volume under this surface. So in a if you want to do volume and you just want to do it as a double integral, it's a double integral over the region, and then you just integrate you're finding the volume under the function dv. And you can do that with rectangular or polar, either one. All right, so let's see here. I think what I want to do is I want to find where that surface intersects the xy plane. And so let me just set z equal to 0. We would get square root of x squared plus y squared equals 4. And so we get x squared plus y squared equals 16. So the region we're integrating over is, again, a circle radius, in this case, radius 4. That does not look like a circle. Okay. Could totally cheat if I was at home. I could like find something circular and just trace around it, and you'd all be in awe at my perfect circles. Like, how did you do that? All right. So this one, I just wanted to mention that this is clearly in the polar coordinates section. But again, even if it wasn't, if this is just an exam question, you see the circle, you should be thinking polar coordinates. Okay, so we have our function 4 minus the square root of x squared plus y squared. And then we're going to do polar, r dr d theta. And since it's a circle again, r goes from 0 out to 4, and theta goes all the way around to 0 to 2 pi. And then just like Max said for the previous one, we have x's and y's here, and we're integrating dr d theta. So we need to modify that 0 to 2 pi, integral from 0 to 4, 4 minus square root of r squared. That's convenient. Normally here, as a note, normally square root of r squared would be the absolute value of r. But for our particular problem, none of the r's are negative. So we don't need the absolute value of r. So square root of r squared, even if you did kind of the lazy thing and just said, oh, the square root and the square cancel, well, in this particular case, you'd be right. They do in this particular case. Whoa. And so this just becomes the integral of a polynomial. It's going to be 4 minus r times r, and you can distribute that r. 4r minus r squared dr d theta. And that's the kind of integral you hope for here. Those don't happen very much when you just end up with a nice little polynomial. You get 2r squared minus 1/3 r cubed from 0 to 4 d theta. Let's see here, plugging in 4, 16, we get 32 minus 64/3 d theta. Make it all into thirds, so 96/3 minus 64/3, so 32/3. And that gives you 32/3 theta from 0 to 2 pi, so 32/3 times 2 pi, and so we get 64 pi over 3. Incidentally here, what kind of surface is there, or what kind of geometric shape is this, by the way, that we're finding the volume of?
Cone.
Yeah, just a cone. And so what if we found the volume of the whole cylinder? It's a radius 4. The height would also be 4. When x and y are 0, we get 4. And so the cylinder would be pi times r squared times h. So that's 64 pi. And then check this out. The cone is 1/3 of that. And that's actually always true. The cone is 1/3 the volume of, oh, you're right, Michael. Yeah, the cone is 1/3 the volume of the cylinder. I just caught your chat, Michael. He is correct. I was just thinking of triple integrals. Another donut point that doesn't matter. That's so sad. This dv here, we're just a double integral, right? So his comment in the chat, I don't know if you caught it, would just be dA there. That's correct. It would just be dA, not dv. Yep, thank you. Leslie, did it answer your questions on number 11? All right, excellent. Good questions so far. What's next? It's quiet today. I do have one more example left over from yesterday that we could do, and that's fine. So any other homework questions though before we move to that?
Could we look at 39 and 16.3?
Sure. Sounds good. 16.3, 39. Oh, this is like the spaceship one. This one's like cool looking region, but like a challenging problem. We did one kind of like it where the core got cut out. We did 38, I think. I think we did 38 in our practice. Okay. Is this the right, do I have the right one, Lizette? This, it was still in,
Yeah.
that's the right side, okay, okay. Are we doing these, is this was that 16.4 or 16? It was 16, no, it was 16.3, right? Can't find it. Yeah, okay. I just was wondering if we should set it up as a triple integral initially or as a double integral. So we are going to do the difference between the two functions. We're going to find a volume here. Whoops, I'm in red. I mean, I guess that's fine, but double integral over the region. And the function that we're going to have here is going to be really the difference in the height. It's going to be the top minus the bottom. We almost have that. We have the bottom one is given to us as this, this is a cone actually. Same cone we just had, right? Square root of x squared plus y squared. And then the top one is a sphere. And again, it kind of has a weird radius, square root of 8, but that's on purpose because it makes the math work out nicely later. We will see. If we solve for z on that, we get square root of 8 minus x squared minus y squared. So the height, the top minus the bottom here will be the square root of 8 minus x squared minus y squared minus, and then the bottom is square root of x squared plus y squared. Then our dA, we kind of have to decide, I guess, right? We kind of have to decide, do we want to use rectangular or polar? I guess, wait, this is, yeah, okay. I keep thinking it was 16.4, but no, it was 16.3. So I'm just hesitating there because we really don't have to decide. It's in 16.3, so we know it's polar coordinates. But again, I want you to be thinking about these things because on the test, I'm not going to tell you, hey, this is a problem from 16.3, or this is a problem from 16.4. It's triple integral. I'm just going to say find the volume, and you can set that up. Or maybe I'll say set up an integral that would find the volume. Now, I might force you and say, hey, set up a double integral that would find the volume, or set up a triple integral that would find the volume. But I want to, you're no good if all you know is, well, this is in the polar section, so I should do a polar, you know? So you're gonna have to make that decision. But here, it's really, it should be obvious that the polar coordinates will be the way to go here. What's the dead giveaway? I mean, maybe, I don't know, maybe it's an obvious question, but what's the dead giveaway here to use polar coordinates?
Whenever there's an x squared and a y squared paired up, you usually want to change that to an r.
That's a really good point, right? There's x squared plus y squareds. Yep. And then also, if you were to imagine, we could graph these if you want, but if you look down from the top, what does everything look like?
The circle.
They're all circles. Everything's circles. So polar is going to be the way to go. So I guess we need to find our region R. And just like we've been doing, I'm going to do the red marker here, kind of highlight over there red. We need to find where they intersect. And so that would be the same thing we've been doing. 8 minus x squared minus y squared equals square root of x squared plus y squared. Find out where they intersect. And you'll see here that the 8 was on purpose. Square both sides. Add x squared plus y squared. And divide by 2, and we get another circle. Oops. This one is a radius 2. So Works out nice. Our region R then is the region outside a circle radius 1 and inside a circle radius 2. Oh, I just had an idea. Is there like, wait. This is going to be well worth the wait. Not really, but it's okay. So what if I cheat and draw circles like this? Oops, then I erased it. Oh man, I lost it. Where did it go? Yeah, nice circles. They're not really line up though, so I might have to just stick to doing them by hand. So we are looking at the region between those, and now they're not centered, so I'm spending more time than I normally would. So I don't think that was an effective strategy there. They do look like nice circles though. 1, oops. 1 and 2. And so the nice thing in polar coordinates is you're finding the area, you're integrating over the region between the two circles. So R just goes from 1 to 2, and theta goes all the way around, 0 to 2 pi. And then just like we have been doing, we need to rewrite everything in terms of R instead of the x squared and y squared. And so we'll do some substitution here. Square root of 8 minus r squared. And then, oh, this is the same thing. Square root of x squared plus y squared would just be r again. R, and then r dr d theta. And I think this was Lisette, I think. Did everything good so far? I think we can keep going, but do you have any questions so far?
No, I guess it's just the setting up, like how you've been
Okay.
setting up for early.
Okay, sorry, should we stop here? Are you good from here, you think, or?
I think I'd be fine from here.
Okay. Let me just do one more step and talk about the plan, and then I think you can probably take it from there. If I would distribute the R here, because you're going to need a different strategy for the two different terms. The second term is obviously just going to be 1/3 r cubed, and then the first term will be a u sub. So you may want to do those integrals kind of separately off to the side.
Okay.
Cool. All right. Any other ones? We've had some good questions so far. Any additional homework questions from 16.3 or 16.4? Okay. Feel free to pop one in the chat if you think of one. We just have, I think, one example left to do from that extra practice. If you don't have this example here, I mean, you can just write it down. But in D2L, can I get, oh, this is the wrong page, but I'll get there. In D2L, under the content, I think I might have linked it here, did I? No, I don't think so. Under the unit 4, and there is a 16.4 extra examples link here. Oh, by the way, I would really like your opinion. You don't have to say it right now because you haven't looked at them yet. But I did some new things, and I'm interested if it's valuable. One in particular. So I had fun with the green screen. That's not really important. But I don't know if it's like distracting or helpful. I put on this tracker where it like tracks where I'm writing. So I don't know if that's helpful. So if you have any comments on them after you watch them and like, oh, that was really help. Like if you don't have anything, like you don't really care one way or the other, that's fine. But if it like made things worse, that would be valuable to know. Right, if it ends up being distracting and it's not good, then just let me know. But I'm at home, I'm having fun. You know, I have a green screen, might as well use it, right? So I've been trying to make things a little fun. Let's do this last one here. This one is gonna be, we haven't done this challenge yet because we don't even know really what our region is. We're just given the bounds, and then we're gonna try to change the order of the bounds. So the only way that I know how to change the order is really to wrap my head around what is this region? So let's take a look here just at Z. Z is going from 0 to the square root of 4 minus y squared. So the first question that I like to ask is, what is that? What is Z equals 0? And what is Z equals the square root of 4 minus y squared? Why don't you take like 30 seconds and think about that? And then maybe like raise your hand. Remember, everybody know how to do that. Like click on, what is it, manage participants, and then you can raise your hand in there. So just let everybody think about that one. We just want to know what those are. What are those? All right, I see 2 raised hands. Max, you answered a lot today, so I'm going to go to Michael. No offense. So Michael Janopoulos, what do you think?
Are they just, is it like a half circle, like projected about the y-axis? Kind of.
I would say if you were to look at this on the YZ plane, it would be a semicircle, but we're graphing in 3 dimensions. So there's a little more to it. Does that help? Maybe?
Yeah, and then doesn't it just go from 0 to 1 on the x? So like you would draw another one of those like half circles.
Sure.
X equals 1, and then
I see what you're saying. So does everybody see Michael's looking at, well, X goes from 0 to 1. So really what this is a cylinder, and it would be extended all down the XY axis, but Michael is correct. We're only looking between X equals 0 and X equal 1. So there's another one down here at 1, and we'll see if I can draw this. There's another one there. I'm trying to draw something like that. Draw a couple more in there. Okay. And then I think the y equals -2 to 2 just kind of filled itself in. I think it did that automatically, right? Because 2 is right here. When z is 0, y is 2, or back over here, -2. So I think that kind of did itself just fine. So we have this surface here is z equals square root of 4 minus y squared. Okay, now though, now we're going to try to find dy first, which seems like a bad choice. You have your little representative cube in here, and you're going to go side to side. Okay, you're going to go from the parabola, or from the semicircle back to the semicircle, just between the 2 sides. I feel like I need to look at this. Can we look at it from the end? Look at it in the YZ plane. 2, 2, 2, and we're going from side to side. Yeah, this seems like a bad choice, but we don't have a choice. It's what it's telling us to do. So, any ideas on getting a lower and upper limit there? Michael says to solve for y. Sounds good to me. So, because the problem is it's going from like y1 to y2. I don't know, whatever you want to call those. It's going from the left to the right. So we need to solve for y. And if we square both sides, we get z squared equals 4 minus y squared. Add y squared, subtract z squared, and you get the same equation. Y is equal to square root of 4 minus z squared. Actually, it would be plus or minus though, right? It would be the left and the right side. Left and the right side of that. So y goes from negative square root of 4 minus z squared to positive square root of 4 minus z squared. And then we're supposed to go z next. And z then, again, you have your little, I think I'm going to stick with red here. You have your little pillar or whatever going side to side. Then you're going to add them up vertically. And what you're going to get is one, whoa, it's like you erased everything. One slice of bread here, basically. You're going to get one slice. So you're just going to add them up from the bottom to the top. You're just going to add the z's from 0 to 1. No, 2. Excuse me, 2. 0 to 2. Top z is at 2. That would just, you could really just look at from the cross section. And then finally, x, we'll add all the slices of bread up here. They're all exactly the same shape. In fact, we would add them all up from 0 to 1. So to me, that would not be obvious to me just doing the integral and like rewriting it. I need to, for me, I need to visualize the region. You can use some technology to visualize it. We can graph that. So we could do display plot 3D. What was it? Square root of 4 minus y squared. X equals 0 to 1. Oops. X equals 0 to 1. Y equals negative 2 to 2. And then I think there's like a filled equals true. I don't know. I don't know if this may not work. Oh, actually, I don't need the display. I can just do that. Yeah, okay. Let me switch the axes. Axes equals normal. There, we need to zoom out a little bit. I kind of made it too big, but there you go. You can see the region. And that might be helpful once you've investigated and seen that z starts at 0 and ends up at this top function. Maybe you just graph it and look and say, oh, okay, well now I need to go from left to right because I need to do the y's first. And maybe I can look at that from the side and say, what does that look? So we were able to do it on paper, but maybe, maybe having a tool like that is helpful where you graph it. You can use one of those 3D plotters and to get a visual of that. For me, that helps me when I'm trying to rewrite it in a different order. I think that'd be hard for me without rewriting it. Okay, any questions on the rewriting of that integral? Okay, last call. Any last questions before we kind of summarize what your tasks are for the week and call it a little early day today? Any last questions? All right, I'm not seeing any. I can hang out for a little bit. Did you know in the chat you can do a private message, by the way? If you go in the chat, there's a to everyone, or you can just go someone specifically. And so feel free to just send me a chat if you want me to hang out and have a question. So for Thursday, you should be working on 6.3 and 6.4 homework. That'll be due Thursday. We can still do some questions on Thursday, but we're going to expect that you will have watched 6.5 for Thursday. There's 3 videos for 6.5. They get like progressively fancy because I was having fun. But 3 videos, I think it's probably like 50 total minutes. It's kind of a longer section. So I want you to watch those for Thursday, and then we'll do some examples from 6.5 if we have time after homework questions. Yeah, and that is it for the rest of this week. Okay. Enjoy the rest of your day, everybody. I'll hang up for a couple minutes, otherwise I'll see you Thursday.
So with your YouTube videos on the editing where you put that little dot there,
Yeah.
I can't actually comment on that below because I'm using a Chromebook from my high school.
Right.
So they don't allow commenting.
Sure.
But I do like the idea because sometimes like I usually pause it and then write down what you write because you do go a little fast because you can't.
Right.
Right. So sometimes I'm like, I'm just like looking. I'm like, where is he at? And then
That's
some,
what I
like,
was
writing
thinking.
just pops up.
That's
Okay.
what I was thinking because I was like, how do they know where I am? Or like sometimes I'm hovering my pen and kind of circling,
Mhm.
but I don't think it puts a cursor there. Like, so you
Yeah,
don't
yeah.
really know like what I'm indicating. So that's cool.
Yeah. I find that helpful.
Cool. Well, we'll see. Like I have a lot of flexibility on it. So what I did is just kind of made it relatively small and made it the same kind of blue that I draw with. But I can make it like yellow. I can make it really big. Like there's all these cool things you can do with it. I can make like my own little pen, but that looks really, really stupid. So I don't think I'm going to do that.
All right.
Cool. I appreciate that, Max.
Yeah.
All right. Take care. Leslie, anything I can
All
help
right.
you with before I sign out? No. She must have stepped away. All right. Cheers, everybody. We'll see you.
Bye.